Bismillahirrahmanirrahim. My name is Saba Tahir and today's my topic for presentation is radium. What is radium? Radium is actually an element, a chemical element of atomic number 88, a rare radioactive metal of alkaline earth series. It is the most radioactive element on the earth. Discovery. It was discovered by Marie Curie and Peary in 1898. Here is the structure of radium. Its atomic number is 88. Its atomic mass is 226. Its symbol is Ra. The electronic configuration of radium is 7s2. It has 2 electrons in the outermost shell. Its name is radium. Its physical state at 20 degrees Celsius is 68 degrees Fahrenheit. It is strongly basic and it occurs in the alkaline earth metal. So here is the structure of radium. Electronic configuration of radium. The nucleus consists of 88 protons. What are actually protons? Proton is a stable subatomic particle that has positive charge equal in magnitude to the unit of electron charge and rest mass of 1.67 into 10 raised to power minus 27 kilogram and 138 neutrons. Neutrons are actually the subatomic particle of about same mass of proton but without an electric charge. 88 electrons successively occupy available electron shell ring. Radium is a radioactive alkaline earth metal in period 2, in period 7, group 2, and the S block of the periodic table. Here is actually the electronic configuration of radium. Radium has atomic number 88 and its atomic mass is 226. It has 2 electrons in the outermost shell. So this is the electronic configuration of radium. Isotopes of radium. What are isotopes? Isotopes are actually the atoms of element having same atomic number but different atomic mass. While there are 254 stable isotopes, more than 3,000 radioisotopes are known, of which 84 are seen in nature. The radiation emitted is energetic and can be of different types, most commonly alpha, beta, and gamma. For example, radium-223, which is actually the isotope of radium, is used for the treatment of cancer. Reaction of radium with alpha particles. What are alpha particles? Alpha particles are called alpha rays or alpha radiations, consist of 2 protons and 2 neutrons. Alpha decay occurs in the nuclei of heavy elements like radium, uranium, thorium, etc. When a nucleus of radium decays, it emits an alpha particle and becomes an radon nucleus. In general, during alpha decay, the atomic number is reduced by 2 and atomic mass is reduced by 4. Here is the reaction of radium with alpha particle. In the first reaction, radium, its atomic mass 226 is reduced by 4, 222, and its atomic number 88 is reduced by 2, it becomes 86, and radium becomes radon and it also emits an alpha particle 42. In the second example, uranium 238, its atomic mass is reduced by 4, 238 to 234, and its atomic number 92 is reduced by 2, 90. And uranium becomes thorium, and it also emits an alpha particle just like radium. So these are the 2 reactions of radium with alpha particles. Manufacturing of radium. Radium is present in all uranium ores and could be extracted as byproduct of uranium refining. What is refining? Refining is actually the process of reducing impurities in a substance. Uranium ores from DR Congo and Canada are richest in radium. Today, radium is extracted from spent fuel rods from nuclear reactors. Annual production of this element is fewer than 100 grams per year. Properties of radium. Here are some physical properties of radium. What are physical properties? The properties, those are associated with the physical state of a substance are called physical properties. For example, taste, smell, melting points, boiling points, temperature, etc. Here are some physical properties of radium. Melting point of radium is 700 degrees Celsius. It actually melts at 700 degrees Celsius. Boiling point of radium is 1140 degrees Celsius. At 20 degrees Celsius, it is in the solid state. Radium is naturally occurring element that is present in the rocks and soil within the earth crust. Radium has no smell or taste. Radium is silvery, lustrous, and soft, intensely radioactive. It is most volatile. Volatility describes how easily a substance will vaporize, turn into gas or vapor. Here are some chemical properties of radium. What are chemical properties? The chemical properties depend upon the composition of a substance. When a substance undergoes a chemical change, its composition changes and new substances are formed. For example, decomposition of water is a chemical change as it produces hydrogen and oxygen gases. So, here are some chemical properties. It really oxidizes on exposure to air, turning from almost pure white to black. Radium is luminescent, corrodes in water to form radium hydroxide. Radium is used in the luminous paints in the form of radium bromide. Radium paint is actually self-luminous. When freshly applied, it requires no external energy because the excitatory energy comes from radiation emitted by radium particles in the paint. Here are some commercial applications of radium. The most important commercial application is its use in the medicine. It is used in the medicine for cancer patients. Commercial applications of radium are: it is used in the nuclear medicine at Paris, St. Louis Hospital, Henry Alexander Daniels, and P.D. Curie used radium for the treatment of skin cancer. Radium 223 used, which is radium 223 is actually the isotope of radium used to treat cancer in bones that begin in prostate. Radium 223 treat cancers in more than one area of bone and helps to reduce pain. Radium 223 dichloride is a radioactive drug that behaves in the similar way to calcium and collects in cancer that has spread to the bones. Bone metastasis is actually the bone cancer. The radioactive particles in the radium 223 dichloride act on the bone metastasis. They actually act on the bone cancer cells, killing the tumor cells and reducing the pain that they can cause. Radium 223 actually showed a clinical benefit with a reduction in pain symptoms in 58% of cancer patients. Radium 223 was shown to be an effective and well tolerated therapeutic option in cancer patients. So, here is my presentation about the element radium. Thank you so much.